All right, so today we're diving into the world of AI, but not the kind that's just, recognizing cat pictures. We're talking about AI that sees the world like we do, through its own eyes, so to speak. Robots, smart glasses, you name it. And this paper you sent in, it really digs into the challenges of making this embodied AI thing a reality.
What's so intriguing about this paper, I think, is how it tackles this really fundamental challenge,
Yeah.
getting AI to actually connect thought and action. And not in some like pristine digital world, but in this messy, unpredictable world we live in. It's not just about recognizing a chair in an image anymore. It's about understanding, okay, how do I walk around that chair? How do I reach for something on? How do my own movements change what I see?
Right, it's like it's easy to recognize a coffee mug in a photo, but actually picking it up without spilling, that takes a whole different kind of understanding.
Absolutely. And that's something we as humans, we take it for granted, this whole spatial awareness thing. But for AI, totally different ballgame. And that's where this research is so important. It's really pushing the boundaries of what AI can do with this egocentric viewpoint.
Okay, so no more AI just chilling in the digital world. We're talking about AI that has to deal with spilled coffee and all that.
Exactly. Spilled coffee, cluttered desks. It needs to understand when I move, the world moves with me. And that might sound simple, but for AI, it's incredibly complex to grasp.
This makes me think about all those sci-fi movies with the super realistic robots. If this research is so important, why aren't we seeing more of that in real life?
Well, the truth is, the technology is still catching up. And this paper actually highlights that. Even the most advanced AI models right now, they hit a wall when it comes to certain tasks. Tasks that we, as humans, find pretty intuitive. Understanding the flow of actions in a crowded room. Predicting what's going to happen next, even just grabbing an object without knocking everything over.
So how do researchers actually test this kind of AI? It's not like they can just set a robot loose in a room full of, like, expensive vases.
Right, and that's where this new benchmark they introduced comes in. They call it VidEgoThink. Think of it like an obstacle course, but for AI.
An obstacle course for AI. Okay, I'm game. So how does this VidEgoThink thing actually work? What kind of challenges are we talking about here?
So they designed it to test 4 key capabilities, the kinds of things that are essential for this egocentric vision. And they're using real-world footage to do it, thousands of hours of it. We're talking about videos of people doing everyday stuff, cooking, cleaning, playing games, all from that first-person perspective.
Wow, so no more like perfectly curated data sets. They're really throwing the messiness of real life at these AI models.
Exactly, and that's where it gets really interesting. Because we start to see, okay, which models can actually handle the chaos of the real world and which ones just totally fall apart. One of the key capabilities they're testing is this idea of video question answering.
Video question answering. So like if I'm wearing these smart glasses and I'm ripping up a batch of cookies and I ask, did I already add the vanilla extract?
Exactly. But think about what the AI actually needs to do to answer that. It has to track what happened earlier in the video, right? Recognize the vanilla extract bottle. Understand the action of pouring, and then analyze the current state of the mixing bowl. And it has to do all of that with all the visual clutter and variation of a real kitchen.
Right, and I'm guessing a simple yes or no, that's not going to cut it here. The AI has to actually understand what it's seeing, not just...
Exactly.
Yeah.
It's not just about recognizing patterns anymore. It's about understanding actions and their consequences. It's about following like a narrative thread across time. It's a whole different level of complexity.
Okay, so that's video question answering. What about the other challenges? This VidEgoThink gauntlet sounds pretty intense.
So another capability they're testing is hierarchy planning. It sounds kind of technical, but we do it all the time without even thinking about it. Think about something as simple as making a cup of tea.
Okay, so I walk into the kitchen, kettle in hand.
Right. So even a task that simple, it involves a whole hierarchy of smaller steps, Fill the kettle, find a mug, grab the tea. Humans, we just naturally break these complex goals down into manageable chunks. But for AI, that's a real stumbling block.
So it's not enough to just recognize the objects. The AI needs to understand the steps, the how-to of it all.
Exactly. Like it needs to become a master chef of everyday tasks. And that means it needs to understand how actions relate to each other, how to create a plan, and even how to adapt that plan when things go wrong.
Which, let's face it, in the kitchen always happens. All right, so we've got our AI contestant trying to answer questions about videos, learning to make the perfect cup of tea. What else does this VidEgoThink obstacle course throw at them?
This is where we get into some really fascinating stuff. They're also testing something called visual grounding.
Visual grounding, does that mean the AI gets put in timeout if it messes up?
Not quite, although I'm sure some programmers have considered it. Visual grounding is all about connecting language to the physical world. It's the ability to link words to the objects and actions they represent.
So, like, if I tell my smart glasses to find my keys, they need to actually know what keys look like.
Exactly. It sounds simple, but it requires a really, really deep understanding of both language and visual information. The AI has to bridge that gap between what we say and what it sees. And honestly, even the most advanced systems out there are still struggling with that.
It's like we're trying to teach AI to see the world through our labels, to understand that connection between what we say and what they see, which I imagine leads to some pretty interesting misunderstandings.
Absolutely. And that's exactly why this research is so important.
Yeah.
Pushing these boundaries, challenging these AI models with real-world situations. We learn more about not just their capabilities, but also their limits.
Right, because knowing what AI can't do, that's just as important as knowing what it can do. Okay, so we've got video question answering, hierarchy planning, visual grounding. What's the final challenge in this AI obstacle course?
The fourth one is called reward modeling. And this one's really interesting because it forces us to define what success even means in a way that an AI can understand. It's like we're trying to program in the very definition of a job well done.
Okay, now I'm really intrigued. Break this down for me. What does reward modeling actually look like in practice?
Okay, so imagine you ask an AI-powered robot to tidy up your living room, right? How does that robot know when it's done a good job? How does it know it's actually achieved its goal?
It can't just be like recognizing a messy room versus a tidy one, right? It has to understand what actions actually lead to that tidy room.
Exactly. It's not enough to just, understand it in theory. It has to translate that understanding into action. It needs to know, okay, picking up these clothes and putting them in the hamper, good. Leaving them scattered all over the floor, not so good.
Right. It's almost like it's like training a dog with treats, you know? You use positive reinforcement to get the behavior you want. Except here, the treat is the AI getting like a digital pat on the head for a job well done.
Yes, exactly. And just like training a dog, it takes a lot of repetition, a lot of fine-tuning to get it right.
So they're really putting these AI models through their paces with this VidEgoThink thing, testing their ability to answer questions, plan tasks, understand our language, and even strive for success. But how did they do? Did any of them come close to acing this AI obstacle course?
The results were illuminating, to say the least. They tested a whole bunch of models, from those big fancy API-based ones like GPT-4, to open source models that anyone can tinker with. And what they found is even GPT-4, with all its hype, it really struggled with some of these egocentric vision tasks.
Oh, wow. Really? I thought GPT-4 was supposed to, like, the be-all and end-all. What tripped it up?
So one of the things they found was GPT-4, it really relies on having a lot of visual information to work with. When they limited its input, like just showed it a few frames of a video, its performance tanked, especially on things like predicting what happens next or understanding the long-term consequences of actions.
Interesting. So it's like trying to understand a whole movie by just looking at a couple of random stills. You might be able to recognize the characters, the setting, but you're missing all the nuance, all the plot details.
Exactly. And that's what these AI models are struggling with. They can recognize objects, maybe even simple actions, but understanding the flow of events over time, grasping that cause and effect, that's where they're still way behind us.
So even the most advanced AI today, still kind of like a movie buff with a really short attention span.
You could say that.
Yeah.
But the good news is this research gives us a much clearer picture of, where AI excels, but also where it needs to improve. It shows us where we need to focus our efforts if we really want to create AI that can see and understand the world like we do.
Okay, so we've talked about the challenges of egocentric vision, this VidEgoThink benchmark, and even how GPT-4, as impressive as it is, still has its limits. But what does all this mean for us, the non-AI folks? Why should we even care about all of this?
Well, because this isn't just about robots and smart glasses. This is about how we, as humans, are going to interact with technology in the future. Imagine a world where your smart home actually understands your needs, not just responds to commands, where your car can navigate a busy city street as easily as you or I can, where AI can assist us in ways we haven't even thought of yet.
Okay, now you're talking. Give me some concrete examples. How could this technology change our lives in the next, say, 5 to 10 years?
Let's take something we're all familiar with. Virtual assistants. Right now, they're pretty good at, following simple instructions. But with this kind of egocentric vision, they could be so much more intuitive, so much more helpful. Imagine a virtual assistant that can actually see what you see, understand the context of what you're doing,
Yeah.
and offers suggestions or assistance that are actually useful.
So no more like endlessly repeating, set a timer for 10 minutes because it can't understand your accent.
Exactly. But it goes way beyond just convenience, too. This technology could completely revolutionize healthcare. Think about AI-powered assistive devices that can help people with disabilities navigate the world with more independence. Or personalized education software that adapts to each student's learning style.
This is pretty mind-blowing stuff. We're talking about a future where AI isn't just a tool, but a collaborator, a partner in helping us navigate the world around us.
Exactly. And that's what makes this research so exciting. It's not just about making AI smarter. It's about making it more human-centered, more aligned with our needs, our goals, our understanding of the world.
I think that's a fantastic point to end on. It's been a real pleasure exploring this with you.
Thanks for having me.
And to you, dear listeners, thanks for joining us on this deep dive into the world of AI that sees. Until next time, keep those minds curious, and we'll catch you on the flip side.